That's right.
Oh, dang. All right, class 6.3, let's go. This is trigonometry equation involving multiple angles. And we're going to go through a few things here. So let me go back to here. Number one, we're going to solve just simple trigonometric equations. The next is identify how to solve trigonometric equations. This is interesting. Okay, then we have the quadratic formula on our hands. Oh, wow. And then we got a real life problem. So don't need to write those down, just kind of think in your mind. That's what we're going to do. So basic ones, sometimes when you need to use the identity, sometimes when you need to use the quadratic formula, and then just do an application question. Let's jam. Example one. Oh, I've seen that one before. Just a slightly different number there. All right, so sine 2 theta is equal to negative root 3 over 2. Raise your hand if you do need the formula sheet. Anybody need a formula sheet? We're not experts here. Okay, using your formula sheet, since sine theta is by itself, or the trig function is by itself, go tell me what degree value makes that true. I think we're looking at quadrants 3 and 4, is that right? Yes, okay. Quadrants 3 and 4. I'll sing Jeopardy. Dun, 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 dun. How many do need a formula sheet? Anybody need a formula sheet or the even circle? So in front of? It's only half of the formula sheet for the test. These are the important ones. Raise your hand. Anybody else need us? Count them. Yeah, as long as you have them. Fine. Yep. Okay. Okay. Give me sine theta being equal to negative root 3 over 2. Give me the angle value. I can pick up people here. So let's go from Lucy. Okay. Ouch. Let's see. Going on. Hannah, can you help us out here? Or actually, let's do tables here. Hannah or Maya? Give me sine giving me a negative root 3 over 2. When does sine give me a negative root 3 over 2? So sine is going to be my y coordinate. Is that right? Y coordinate, unit circle, y coordinate, root, negative root 3 over 2. 240 and 300. So you guys agree there? I agree. Yep. So let's go then. Yeah, you're going to look at something like this and like that. And if you go over here, that's 240. Go around, it's 300. Perfect. So let's set it up here. So 2 theta is equal to 240 plus 360k. The other one would be 2 theta is equal to 300 plus 360k. And then we do exactly what we did on the board. Like that. And we did a problem like that. We divide by 2. And we're going to use k is equal to 0 and 1. True, true? So 2 revolutions around the unit circle. And we got ourselves that equation gives us all of them. Because we're going to get all the solutions first. And then from there, we're just going to pick out the ones we want based upon how many revolutions we have. And divide by 2, divide by 2, divide by 2. And I got myself 150 plus 180k. So the half revolutions only work when you are dividing by 2. So now, in your mind, if you guys can you guys give me the answers Like if k is equal to 0, what would be the answer? That was the easy one. 120, 150. If k is equal to 1, what would be the answers? Because you guys are sophisticated trig students, you guys can do that in your head. 300. It's 120 plus 180, and 330. Okay, it's 180 plus 150, right? It's these two together. We don't need to go on because notice 330 is pretty close. If I had k is equal to 2, then I would definitely go beyond 360, right? So your answers are going to get kind of close to 360, but not going over. You guys talk to me. Does that make sense? I think with the one on the board, it kind of was easy. Fine. Yeah, if k is equal to 0, this goes away, right? K is equal to 1, so that means we put a 1 in here. So 1 times 180 is 180. And 180 plus 120 would give me 300. So it's just technically adding these two together. Gotcha. Just the addition of that, whatever is multiplying k. Sweet. All right, example number 2, all yours. Let me just walk around. Another easy one, just to sort of solidify that. All yours, go. Then we'll get into some funner stuff. All right, let me walk around. You guys ask me if you guys need any help with it. All right, yeah, this is still in degrees. That's kind of nice. Eventually, Sure. So yeah, not always going to be 180K. Not only going to be half the revolution. All right, I got a few people waiting for me. A few people almost done, so I'm going to go for it here. And then you guys catch up if you need to catch up some more here. So let's go with cosine being positive 3/5. That's going to be quadrants 1 and 4. We good? Quadrant 1 would be 30 degrees. What? No, can't. Did I mess up?
Yeah.
Yeah, I messed up.
300.
I messed up this time. Okay, you guys help me out. 30 plus 360K, is that right? Yeah. And we got 2 theta 3.
I can buy something.
So then, again, just getting to be a little easier here. 15 degrees plus 180K. Divide by 2, divide by 2, divide by 2. Sorry, I didn't in the screen here, but this would be anyway 330 divided by 2. What's 160? Plus 180. And then answers are 15. I'll do the top one. So we took this one. We found out with because of your identity, we found out that this guy is when cosine is equal to 30. trying to figure out. We don't care about the 2 theta yet. We just care about when the angle is. So you're looking for a x coordinate that's a positive root 3 over 2. It happens there. And let's see if this one works. And it happens here. That's 30. That's 3.
Neither side.
Did I work it now? Yeah. Did I erase? Yo. This one? 195? Yeah, but this comes from 15 plus 180. Plus 360K. All of them are going to be plus 360K because revolution will give us the same answer again and again and again.
I know, it's really good. It was just your face was so funny. The honors tea, she got like a cup of tea, and I guess she thought it was like some kind of other tea, but it was just,
How are you trained?
Yeah, and then going through the chat, right? Or they would use cases of 0, 1, and 2. So it's 1 less than.
It's actually so I feel like on a Nintendo DS. I played on the DS. Yeah, right. League of Legends is one of the best games. No, you have to experience it.
Let's see if I can pass my mess up here. Oh, I still got to erase all that stuff there. All right.
no, it's in green.
It's cotangent.
Listen, we have notes about Napoleon. Napoleon, like the short guy. Right, but we have like notes on it.
Yes, but
All right, let's go with it. Cotangent 2. Oh, no, 3 theta now.
it's like specific for a
So first things first is
Yeah.
cotangent is not on our
James
note
said that
sheet.
he knows that
So here's what we're gonna do.
based on the furnace side, if they brought up Napoleon, that they're his officer.
Telling Jaden, let's go with it. Cotangent 3 theta is equal to 1. We're in radian measurement now, and cotangent is not one we like. But here's what we're going to do. We are going to flip it around, because that guy's the same thing as that guy over 1, is that right? This guy's the same thing as this guy over 1, and I like tangent instead. We don't want to convert it to cosine and sine. I've got 2 trig functions. So here's this, I'm going to invert this guy, and it's tangent 3 theta. What's 1 divided by 1?
0.
1. Good, good. All right. So now the question is, can I do this? I'm going to try to figure out when tangent is equal to 1. So on your unit circle, think about when is tangent equal to 1, or when is the x and y values exactly the same. That's what you
tangent was 1 over. I thought tangent was 1 over.
Yeah, so it is. I flip those around. So, tangent is.
Tangent's 1 over cotangent, right? Not cotangent over 1.
So what it is, I made this right here to 1 over cotangent. 1 over cotangent 3 beta.
Mm-hmm.
And then I converted to tangent. So I flipped it. So let's do this here. We got a question on the board here. How did that happen? Never mind. I was so cool that I did this.
Oh, okay.
It's because of this little rule right now. So you guys talk to me. You agreed or disagreed? What did he say? True or not true?
I might just be something.
What do you guys say? True or not true? If that's true, is this true? Oh,
Student judge.
since Keaton asked the question, Keaton, you got to answer now. If this is true,
Yeah. Yeah. It was just weird because the one, so it was like,
so if the ratio is similar, the ratio is similar.
no. There's never a part where like the.
That's disgusting.
It's just always.
Here we go. I got it at pi over 4, and I got it at 5 pi over 4. We good. Good. Let's go with it. So we got ourselves the 3 theta is, oh, this is not going to be fun because we have fractions with fractions. Oh boy. Okay. So are we okay with, you know what I'm going to do? Also, leave a little bit of space right here. I'll tell you why in just a bit here. Leave a little space after the pi over 4. Can you write this down? And you're going to have 3 theta is equal to 5 pi over. Leave a little space again after the 5 pi over 4. And we're going to do some little bit of arithmetic gymnastics here. You guys ready? So here it is. I'm going to divide this by 3. Dividing by 3. You guys talk to me. Is that the same thing as multiplying by 1/3? Yes. So I can divide by 3 here. I can multiply by 1/3 over here. Are we okay there? And then I can divide by 3 over here. Good. So I got myself pi over 12 plus 2 pi. 2 pi thirds. Is that right? 2 pi thirds? Times okay. Again, same thing here. Divide by 3, multiply by 1/3, and then divide by 3. So how about a theta is equal to 5 pi over 12 plus 2 pi over 3k. So if you guys remember, sorry, 1 second. Pi over 12, that is 15 degrees. Just so you guys know, right? Pi over 12, if you converted that, if you want to think about it in degrees. 20 questions, right? Cool. We good? Thank you so much. Thank you for helping out. Okay, I got myself, let's see, k is equal to 0, 1, and 2. Can you guys plug those in? So can you guys plug in k is equal to 0? Let's go.
Go back like a second.
One second.
Oh.
Gotcha. All right, let's go. So all yours, go for it. Take k is equal to 0. Gotta plug those in. Those are the easy ones. If k is equal to 0, two answers are pi over 12 and 5 pi over 12. Easy enough. And now it gets a little bit more complicated because angle measurements and degrees are a lot easier to add in our heads. This one's going to be if k is equal to 1. So if k is equal to 1, I have here as I have a pi over 12 plus 2. Oh, you know what we can do? How about this, guys? How about if we make the common denominators already? If it was a 2 pi over 3, would that be the same thing as 8 pi over 12? 9 pi over 12. This one, the same thing here. All right, and if you have a 9 over 12, you have to reduce that. So you can't leave it as 9 over 12. It has to go down to a 3 pi over. Next, the other one, 5 pi over 12, and let's make those common denominators. What would that be as a common denominator? Oh, it would be the same thing, wouldn't it? Still be an 8 pi over 12. Answer here is 13 pi over 12. That one you can't reduce, leave it alone. And then your job is to do k is equal to 2. Go for it. Do the last one. Okay, yeah.
I thought I asked you and you said no. I was confused. I was like, what do you mean?
I think the highest I go is 4. That's too mean.
8
That's
theta
too mean.
equals 24 theta equals 2400 degrees.
Maybe a challenge problem. Something like that, yeah. Okay, k is equal to 2. Let's go with it. K is equal to 2 goes, sets us up at pi over 12 plus. Yeah, always 1 plus
Oh,
that.
wait, what?
All right, anybody know why I put a 16 over 12 now?
Because it's like 2.
Yeah, if k is equal to 2, so it means 8 pi over 12 times 2, right? Because k is, I got a 16 pi over 12. And final answer is, oh, do I need to reduce that one?
No.
Yeah. Perfect. By 3. Alvin is correct. 7 over 4. Dun, da, da, da. Okay, listing all of them. Just 5 pi. All right. Talk to you if you need more time here. That is the end of the basic ones. Now we get to the funner ones. And I'm going to go just a little tiny bit faster just because of time. Oh, of course, yeah. All right, then we're all good to go. Anybody need more time? I like that. So let's go with it. Here's what I got. I have sine. Oh, wow. A whole big old thing here. Anybody know maybe some kind of identity that may simplify this? Anybody have an identity that says cosine times cosine plus sine times sine? Oh, this is the difference formula for cosine, is that right? This is just going to be cosine of a minus b. So you just make sure it fits the formula exactly. Good. So our a value is 2x. Our b value is x. Oh, this is nice. Tell me if that makes sense there. Jada, let's go with this one here. So we got, oh, and this one actually says find all the solutions. Oh, that's actually a good thing. Show you why in just a bit here. If it says find all the solutions, that's a better way to do it. So this is just the difference formula for cosine. Plug it in. 2x minus x is just an x. Anybody on your formula sheet give me when is cosine x 1 over root 2? In radians or degrees? In radians. All right, anybody in radian measurement, give me 1 over root 2 for cosine. 5/4 is one way, yep. 7/4 is another one. Perfect, I got those two, and here it is what I got. X is equal to, now notice it's not 2x, right? It's just x. Oh, and then, sorry, write this correctly here. Notice it says find all the solutions, right? Not from 0 to, oh, if x is measured in radians from 0 to 2pi. Never mind, it is from 2pi. But we didn't have to do a multiple measure, right? We'd have to do a multiple of our angle. So that is it right there, all done. So we only apply this little k value in 360, right? Only if there's a 2 theta or 2x, 3x, 3 theta, 4x. This one we can just do regular. Okay, next. Just when I said I'm not going to be cruel.
She did.
So,
It's like we're your customers.
all right, I will tell you why this is not a cruel problem, because it doesn't say find it from 0 to 360 or to 2 pi. It says all the degree values everywhere. So all we need to do is get to k and that's it. We good? So if we are to add 1/2 to both sides, give me the times when cosine gives me 1/2. Oh, in degree values, right? So I heard 60 degrees and 300. Perfect. So in this case, because we don't have a value up to 360, it's just going to be this guy and this guy. The only other thing we got to do is divide by 8 on each side. So all yours, go for it. What is 60 divided by 8? It's a number, absolutely. Uh-huh. 7.5. Okay, perfect. Don't disregard all those 0 to 7. Yeah, just divide by 8, and I got myself 7.5 degrees. 360 divided 8.
45.
Perfect. And done. So this one's going to be divide by 8, divide by 8, divide by 8 as well. So that's going to be 37.5 degrees. I forgot the little degree symbol there. The only thing we got to do here is what? Say that k is an integer. We good? That takes care of all of the answers everywhere, both the plus way and the minus way. Okay, I like those better. That was the second part. You don't need to plug in the keyboards. That'd be a long time. From 0 to 360 or from 0 to 2 pi. Yeah, then you only got to give you these. Right? Yeah, so if it did say up to 360, then we would have plugged in k is equal to 0, 1, 2, 3, 4, 5, 6, 7, and done each one of those. Okay, so those are the ones that were just a little bit more beyond. So now let's go to the ones that require factoring or quadratic formula.
Wait,
Oh, I like this.
do we have to solve for k?
Again.
We have to solve for all k.
Let's see. It says for all radian measurements. It doesn't give us a defined domain. We good? So nice. This is one of those where we just put k down. Anybody help me out? How do we solve this? Quadratic formula or factoring, right? Whoa. Yeah, someone's having a debate. I'm going to add. All right, I'm going to try to factor this down. Let's see if this makes sense. In order to get a 2 sine squared 3 theta, it would be there either be a 2 sine, should be a 3 theta, 3 theta. And the one over here is a 1. So I somehow have to get a, oh, it's just going to be plus 1, plus 1. All right, let's go with it here. So I'm going to solve each of these, right? Set each of these guys equal to 0. So sine 2 sine 3 theta plus 1. Isn't this kind of crazy, guys? We're doing equations with letters inside them. So how about subtract 1 divided by 2? Let you finish that one off. And then I got my sine 3 theta is equal to negative 1. So remember, we don't need to plug in k values, right? Just give me the k values. So can you guys finish it off from here? Go. Eli, question? 2. The last problem. Yep. Let me just give you guys this here to do, then we'll jump to the last problem. So I factored this down. I set each of them equal to 0, and I solved for each of them. And now I need to, for those of you that can do it real quick, if I switch back. So just give me these right here, and then eventually write k as an integer, but you have to solve for theta, right? So theta equals. And we are in radians. Sure, radians, and let me jump back.
Spanish.
Okay, you like question on this one? That one and that one. Okay, good with that. Eli, done with that one? Okay. All right, first one. You guys okay here? Sine 3 theta is equal to negative 1 would be 3 theta is equal to 3 pi over 2 plus 2 pi k. And here's, and the other one here. When is sine going to give you a negative 1/2 of anybody? Quadrants 3 and 4? 7 pi over 6. Perfect with that one. 11 pi over 6. Okay, so I got 3 different answers. Kind of just don't mess it up in your mind here. I got this one here. this one, and then I got this one. So 3 different answers. Now I got to divide each of those by 3. And sometimes the 3 will cancel, sometimes it won't, just depending. All right, and I'm gonna let me rewrite the answers here over here on top. Rewrite it. That was the first one we got. That was the second one we got, and that was the third one. Let's divide everything by 3. So if you divide that by 3, what do we get? In your mind. I can pick on people, huh? Let me pick on people. I only picked on Hannah and Maya. That's not cool, right? Weston and Jaden. I need you guys to tell me what is this right here divided by 3. This one right here.
Oh, I got you. 7 pi over 18.
Perfecto. Oh, nice. Cool. Okay, and Keith and Calvin. All yours here. What I got? Perfecto. Perfecto. Awesome. And Lucy Tony. And Lily can help too, maybe. Might just do like phone a friend. Yeah, in your mind, can you do that divide by 3? But 3's will cancel, so you're still left with pi over 2 plus. But don't forget that. And I heard you. Okay, are we good there? So the pi over 2, are we okay with that? Kind of did it mentally in our heads. Okay, and then we got to do one with the quadratic formula. Eli. Sure stuff. Gotta give you the fight.
It's crazy because
This is how the syllabus for the year, so I gotta give you verbal fight.
yeah, we have like a
Yeah, keep it.
so it is.
So
that way
the list, I
there's
can
that way
rock
off.
lists out.
That way it's 237 pages.
203.
I'm sorry. Because that's better.
Gotcha.
Or like that. We can't use editors. That's how you beat this.
Eli, I'm gonna go on just so we can pick up that one process and come back to it.
We want to win.
All right, class, one last one here. Let's go with it. So, and I didn't find solutions from 0 through 60. Round to New Year's 10th, we're in degrees, and we're gonna have to use a calculator. And it's a tough one. And I got about 5 minutes, so we're gonna go kind of fast. So let's go with it. So write down the problem, and we're gonna go through it kind of quickly here. So 2 sine squared, 4 theta this time, minus 2 cosine 4 theta. Oh, yes. So what's your linear form? Which trig is the linear form? Cosine is your linear form, right? It's the one that actually has cosine, not squared or anything. So we're going to have to change this guy into cosine. And my mouse is dying. We're going to go faster. All right, boom. So we're going to plug in the 2. So 2 times 1, 2 times all of that. And then let's see, then I'm going to move the 1 over. Okay, we're good? So I'm going to go, I'm kind of going kind of fast. So see if this makes sense to you guys in your head here. So I'm moving the 1 over here. So it'll be a -1. But then I have this little +2. So technically it's 2 minus 1. Okay. Bless you. So subtract the 1 from both sides, and it gives us that right there. So 7 equals 0. Oh, don't like it. I don't like when I have to factor or do quadratic formula with a number in front is negative. What do I do? Perfect. Multiply through my -1. And Sophie, I heard you say it too. Okay, kind of going fast here, so you guys, right as we go. And this one, if you try to factor it, it will not factor nicely. So you can put a 2 cosine 4x and then a cosine 4x, but it's not going to. So we're going to have to use the quadratic formula. Here we go with 4.5 minutes left. Ethan, no problem. That's not a cool thing. Going back just for a second.
It's my shoulder.
Operation and someone doing it to win infinitely. Cool. Can I go on? Can I go on next one? So this is going to be the quadratic formula. It's going to be, that guy's going to be the A value, the B value, and the C value. So remember, quadratic formula is -b plus or minus the b being squared minus 4 times A times C all over 2 times A. I'm going to look up the quadratic formula if you need to. All right, that's the case. So negative 2. So that's 4, that's 8. That's a -8. So 4 minus a -8 is plus. So we got 12 on our hands. And the square root of 4 is, oh, sorry, square root of 12. 2 root 3, perfect. So I got a -2 plus minus 2 root 3 over 4. And can I reduce this somehow? Perfect, yep. That guy gets reduced by 2, that one and that one. So this will be -1 plus or minus root 3 over 2. All right, with a minute left, let's finish it up. So I need to know this. There's 2 different answers here. With your calculator, I need to know when is cosine going to give you a value of -1 plus root 3 divided by 2. What is that value? It's -1 plus root 3 divided by 2. I think we did this on Monday. So first of all, it has to be positive. Is that right? 0.366 is correct. So we're looking for one that looks like that on your sheet, and this one becomes this right here. What can we do with this one? We can say not possible. Is that right? Because it's perfect. Yeah. So let's concentrate on this one here. So on your calculator, you're going to punch in cosine inverse of 0.366. What do you guys get? Cosine inverse of 0.366. And it's in degrees. Make sure your degrees. Perfect. And make sure you guys get that. Is 68.5. Perfect. So if that is the case, that's in quadrant 1. That's a reference angle, right? So spin it around. It has to be another one in quadrant 4. So it's 360 minus 68.5, right? Quadrant 4. Everybody okay with 291.5? Okay. So I got this. I got 4 theta, and we'll just finish up right here. This And then I got a 4 theta equal to this. So we have to divide by how much? By 4 everywhere, right? And then we're going to use what k values? Careful. 0, 1, 2, and 3. Good? And then we are done. And you guys are out of here. I saw it.
Yeah, it's kind of overused. Yes.
Nice.
I have what? I tried all my guys. I had Fiji for a while. Timber is my favorite new one. It is? I'm running, I think it's Spanish. I have to turn in so much. I'm so excited we start something that's not challenging. I'm still going to do 4.5 and 4.7. Same. I hit turn in 4.5 on 9. You have I also have to do like 3.7 and 3.9. One time I didn't do that.